I am Andrew Godwin. I am a member of the Django core team. Most probably known these days for my work on Django migrations in the past, and these days working on channels, which is what this talk is mainly about. My day job, I work as a senior software engineer at Eventbrite. If you're not familiar, we are a ticketing company, ticket events and races and all manner of things like that. And I have a fun side project of doing network programming for fun. As you will see here, no sane person would probably do this, well, willingly maybe. So let's start a little bit of history. 2015 is when I first started working on channels. Back then, it was the sort of nascent project of like, migrations had mostly been done. It was merged into Django. Some of my fellow Django team members had taken over some of the maintenance. Thanks, Marcus. And so I wanted to work on a new problem. And that new problem, in my mind, was WebSockets and other sort of new forms of protocols on the web. In particular, channels 0.1 and through up to 1.0 had sort of some basic headline goals. The key thing was to add async protocol support to Django. That is for protocols that are not just request response like HTTP is, but have an ongoing socket where you open a socket, you send some stuff down, you send some stuff back, it stays open for a bit longer, and you sort of have much more of a conversation than the single question and answer you get over HTTP. Obviously, for that, the headline protocol is WebSockets. It has a lot of support. At the time and still now, it's quite popular and being used for a lot of interesting applications on the web, real-time things and games, stuff like that. But I also wanted to have things beyond just WebSockets. I wanted background jobs. I wanted other support for protocols as well. And all this resulted in, around 2017, Channels 1.0. It was a good 2 years of work, and I went through it, released it, it was stable, it was being used in production, and it was generally pretty good. It achieved a lot of those top goals I just showed you. But there were some problems. I had made some choices in the design of that. Remember, this started in 2015. This is now 3 years ago. The thing I thought I had to do at the time was to be Python 2 compatible. Django still was. The Django LTS at that point was Django 2 compatible. And so I picked Python 2.7 as my base support language, and thus threw out any idea of async I/O support. I also then picked Twisted for web server, because Twisted is very reliable, has a lot of things you can just plug in and use, Autobahn as well for WebSockets, and I stuck with synchronous Django. I wanted to keep that familiarity and also not rewrite a lot of Django in the process. And so you ended up with a bit of a weird design about how things looked. You had this idea of like, well, you have a twisted web server which is capable of being highly concurrent. It can handle hundreds of sockets at once easily. And you have a synchronous Django process that handles things just in a big for loop and has one thing at a time. And these, of course, can't coexist in Python 2. You can't do that. And so I also had a channel layer. This was a piece that allowed you to take the async scheduling part out of Python and run it sort of as a separate piece of code. In this case, Redis was what I used to power the async part of that kind of stuff. Now, this, of course, is a bit overcomplicated. It gets a bit more so, but also better when you consider you have more than one server and more than one Django process, because most sites aren't just one box. And so what you would do is you would have twisted servers in a sort of array that things could talk to, and then load balance across, and they'd all go through a central layer, and they'd all go through a big pool of worker servers. And whenever you had an event on a WebSocket, it would go into the thing, through the network, find a Django worker, run some code synchronously, finish, and then come back to the twisted server. For Python 2.7, this was about all you could do. I was design limited by my own choices. But as you can imagine, it has too many moving pieces. There's a reason we don't generally have big network layers in the middle of our application stacks. You do need them eventually. One of the things we're learning at Eventbrite is that like designing a service-oriented architecture involves solving a lot of those problems, but most people don't need those, and Django as a framework does not need to help you do that stuff. On top of that, it doesn't have any async I/O support. These days, Python 3 is very commonplace. Most things start in Python 3. We're now at the amazing point where we have libraries on PyPI that only work on 3 and don't work on 2, which is an amazing place to be. And so it felt like it's very much an artifact of the past. It was this sort of remnant of the last hurrah of 2.7. And finally, the design made it very easy to shoot yourself in the foot. Because it was full of these weird synchronous processes and didn't work particularly well, and a lot of the components were invented from scratch, it was a little bit too easy to not deadlock, but to lock up a whole worker process or leave something running too long. And just generally, you couldn't do as much as you could do with full async support. And so one of the things, it took me a while to do this, and I had to sort of sit down and go through it, but I had to admit I was wrong. And I think very important to say this. It's very hard for big projects to take a big turn like I had to do in this case and change your analysis of the problem entirely. But at the end of the day, Channels 1 was a nice research project. It achieved the goals it set out to do. It was not a long-term solution. And so what does a long-term solution for Django and for Python look like? Well, that's kind of what I've been trying to do with Channels 2. Channels 2.0 was released earlier this year. It is a pretty significant change from the previous iterations in the channel series. And I'm going to go through in the rest of the presentation some of those changes and how taking an async much more at its face value has rethought how I think of Django and web flows in general. The key things about Channels 2 are, first and foremost, is Async.io native. This was the biggest cause of the rewrite. Of course, doing this means you have to be Python 3.5. That's where Async.io comes into the standard library. And more importantly, I wanted to use the async def keyword, which is what 3.5 gives you. And I wanted to not only have support for async code, but also for synchronous code. I'll discuss this a bit later, but it's, in my opinion, very important to have the ability to support both of those different things. And so taking this into consideration, and also the history of Python web programming, I had a much more familiar model. Channels 2 runs like this. It runs like normal Python web programs do. You have a web server, and inside that web server, you run your application. In this case, you run Django. It's simplistic. There's one moving piece. There's no network layer hidden in there, mysteriously causing errors. There is still a need for cross-process communication. One of the problems that you find with WebSockets in particular is the applications you build require a lot more coordination and crosstalk between services. And so one of the things Channels does provide still is that crosstalk layer. The channel layer is still there, but it is now an optional component, and most of the traffic does not go through it. It's only for broadcast and process-to-process messaging. If you're writing a chat application, it's there for you. You can say, oh, send this message to all the other people listening on these sockets, and it will do that. It's also deliberately a lot more simplistic, A, to keep it easier to maintain, and B, because it does not have to fulfill that middle role it did before. The end result of this is not a complete rewrite of channels. It was about a 75% rewrite. Obviously, all the code that used to be weird synchronous stuff had to be rewritten. A lot of the twisted code did not. Twisted has very good async support these days, and so I just plugged in an async reactor and changed a few things, and that kept working. But a lot of the rest of it had to change, especially in the Django layer as well. And one of the big problems you get when you get to this point is about how you write asynchronous code. In Python, and the way we do asynchronous code in Python, an asynchronous function and a synchronous function are very distinct. You can't write one thing that satisfies both interfaces. What this means is it's near impossible to write an API that provides both a synchronous and an asynchronous version without sitting there and writing everything twice. This is one of the reasons you see separate libraries for talking to Redis asynchronously or doing HTTP asynchronously. They're just different APIs. You can't handle the same thing in the same place. And so I really had to sit down and work out how to overcome this problem. I don't want to rewrite all of Django to be asynchronous. I'd love to, but I am but one man, and I only have about a day a week to do this in. And we haven't got until the next millennium. And so that was kind of the biggest problem I faced. Before I dive deeper, if you're curious about this topic at all, I have a blog post you can look at that covers the background of how asynchronous and synchronous functions are different in Python. And it has a good coverage of how thread loops work and how the implementation behind it sits. I'm not going to talk about that here, but as some background reading, it's quite a nice high-level idea of why they're different. But the key thing is, and assumption in this talk is they are different. You can't provide them the same way. And this meant that I had to make Django at least partially async. if you're going to handle WebSockets in particular, you have to be async up to a certain point. Like the thing that handles the sockets, the thing that handles the basic business logic has to be capable of keeping that socket open for a long time in parallel with other things. So let's talk about how Django is structured. Django is this basic layer model. This is a simplistic version, but one of my favorite ways of thinking about Django is a series of layers stacked on top of each other. At the very bottom, you have a WSGI handler that takes your incoming basic raw WSGI request and turns it into a Django request object. Above that, you have URL routing that reads the request object, finds a view, and then gives it to the view. Above that, you have middleware. So before you get to a view, you run through some middleware. It adds things like authentication and sessions and all that stuff. Then you come to a view, does business logic and presentation, and then finally, from a view, you're usually talking to the ORM. Obviously, middleware talks to the ORM as well, but this is a simplistic version. Now, that works fine for synchronous stuff, but we need to think about when it's asynchronous. So if instead we do this, we have to introduce a separate layer of stuff that is asynchronous capable inside Django, and that replicates a lot of that behavior up through the stack. So in particular, rather than normal Django URL routing, we have to have a different kind of routing that's async capable, that can coexist like it can with other stuff. We have to have asynchronous middleware, asynchronous views, which we call consumers in channels. So these all mirror their components in the synchronous sphere. But the one thing I couldn't tackle easily is the ORM. And so you can see here the synchronous part is highlighted in this blue square on the left. There is still need to call into synchronous Django, not only for the ORM at the top there, but also, but also if you are trying to call a normal Django view. If you have a site that's mixed between WebSockets and normal Django, you want to call the normal stuff. You have to drop down into normal Django for that. And so I can replace the WSGI handler with an asynchronous version that makes a request object, but at some point you have to drop down into synchronous land. And how do I do that? Well, you can see there, like I've made Django async native most of the way in a parallel fashion, but I had to bridge those gaps at some point. And that really comes down to A, a lot of frustration and weekends tearing my hair out, and B, two functions that were the result of said hair tearing. Firstly, a function called sync to async. Oh, my voice is going. Perfect timing for this. And secondly, async to sync. The idea is these two functions bridge those two worlds. Sync to async can take a synchronous Python function and make it awaitable, and it runs it in a background thread. Async to sync can take a waitable coroutine in Python that's asynchronous and turn it into a blocking synchronous function that pauses the thread you call it from, jumps to the thread, the main thread with the event loop, runs it there, and then jumps back again. And these are the key components of how we managed to get that support for crossing those two worlds into Django itself. So let's go into a bit more technical detail about those particular things. First of all, sync to async. This is in many ways the easier of the two. It's not super easy, but a lot of the things that you need for this are provided by the standard library in Python. So the first obvious thing, well, not obvious, the first thing to note, synchronous code has to run in threads. So we are going to run more than one synchronous function. We can't just block the entire main thread where the async.io event loop is running. And so we have to have these run in subthreads. Threads in Python are not great. The context switching is a little bit inefficient, as many Python talks have previously said. But they are still useful for things like this, when you want to dip down briefly, run a function, and pop out again. And the standard library has a thing called the thread pool executor, which does just this. You can say, hey, I have a task. You can make a thread pool, and you say, run this in that task, run this task in that pool, and give me the result back. The simplified code looks a bit like this. There's a few more exception handling pieces around this in the code we have in channels, but the basic flow is similar. You find your event loop, you make a future that represents running your task in a thread pool, and then you just await on the future. When you call await here, behind the scenes, the thread pool spins up and runs your task, and then your coroutine that you're writing this in will just pause and wait for the future to return once that thread is complete. Now, this is mostly used for things like calling the ORM, rendering templates, other parts of Django that you saw crossing that boundary just now, where like, okay, I need to talk to a bit of Django that existed before, that is synchronous, and that has to run in a thread. The ORM is particularly tricky. Django has connection handling that pulls connections in threads and makes sure they're shared between threads properly, that relies heavily on a request-response sequence. And so one of the things we had to do was, when you call the ORM in a thread, when the thread finishes, sit there and clean up everything at the end, go, oh, okay, we have to like close connections, stuff like that. And so it's a little bit strange, and one of the unfortunate side effects is you just end up with a lot of outbound connections. The thread pool defaults to 5 times the number of CPUs you have in your machine. So if you have a 16-core machine, you're going to get over 100 threads, all trying to connect out at once to the database. So that surprised a few people, but you can tweak that stuff. But in general, for the smaller stuff, it works really well. The more difficult problem, however, is going the other way. Sync to async is pretty built into the Python core. I think 3.7 has even better support for that stuff. Going the other way is much less common. And this is because async code has to run on an event loop. It has to have the thing that provides it awaitables and provides it the way to do interrupts. And if you're running in a process that we have here, there's already an event loop in the main thread. And the particular problem comes when you're nesting these two things. So say what I've done is I have called a synchronous function from my asynchronous main thread. Okay, we're now in a subthread that's synchronous. I then want to call an asynchronous API in channels from that subthread. So I need to then go out of the thread, back up to the main thread, find the event loop, then come back down again and keep going. Oh, thank you very much. And so it's a little bit tricky. The code is not quite as readable on the screen. It's deliberately tiny, don't worry. It's more than this too. But the basic flow of it is that it tries to go up and find that thread. You can instead try and open a new event loop in the subthread. That is a thing that Python lets you do. You can run as many event loops as you like. But that is going to be less efficient because you are running more loops. They're all listening on more sockets. And so one of the things that Channels tries to do is if you ask for an async function, it's going to pop back up and try and run it on the main loop. And why do we need this? Well, the key reason is, again, I wanted to only write things once. In particular, I had to rewrite, say, authentication for channels. And if you want to have an auth API that runs in both, I want to write it once and then have a compatibility layer like these two functions, make it usable from the other side. And so rather than write things synchronously and have them called in threads, I wanted to write them in the future way, which is write them asynchronously, and if you wanted to, let you call them from old code by using the async to sync function instead. And that really helps reduce the maintenance workload on stuff like this. Because I can just write one set of async APIs and then just say everywhere in the documentation, hey, if you want to call this from a synchronous place, just wrap it in async to sync. That really helps just have like one auth system, one session system, and all the things that Channels provides. Obviously, those things are in Django and Channels, but there are other things too, like the channel layers. If you want to send a message through Redis to a broadcast set of people, that's all async native. It uses AIO Redis underneath. It uses await and async everywhere. And if you're in synchronous code before, you just couldn't call that, which is why they used to be written synchronously. But now you can just say, hey, async to sync this, and then run it wherever you like. You can even use it outside of Channels if you're just in a normal synchronous application and call async to sync. It will then make its own event loop and just run it inside the thread. So it really is usable and flexible through pretty much every place you would try and run asynchronous code from a synchronous context. And the key thing here is that I don't think we'll ever be in a place where we only write one kind of code. At least as it currently stands, Python's asynchronous support is not perfect and certainly not superior in every way to its synchronous support. It is much harder to write and it's much more dangerous in certain ways. For example, if you're not familiar, you can easily just write a function that blocks the entire event loop in Python 3. And if you haven't got the nice debug mode of the event loop turned on, your whole thing will just hang for a bit while the function blocks and then just keep going. And I really don't trust myself to write good asynchronous code. I'm not sure I trust the general developer population to write it all the time either. And I don't think they should. I think the case here is when you need that high parallelism, long-lived support, then you can go async. If you want safety and simplicity, then you can go sync. And that's really one of the ways channels let you do things with both. And that's why I try to keep both systems here. You can just write synchronous Django code and keep things working and have backwards compatibility. You can also go into the brand new, shiny async world and keep things there. You can even have a version of consumers where it goes synchronous in the consumer layer before the ORM layer if you want to write your code that way too. But there is one part of this diagram that's still interesting, and that's this section here. There is a line from the outside mysterious world into my chart. Now, in the first chart, with the normal Django one, that is WSGI. We all know and love WSGI. It's been around for ages. It is an incredibly successful interface that has let us swap frameworks and servers freely. It's let a lot of new servers spring up in the Python world. Like when I started doing Python, you were locked to certain servers by certain frameworks. Like you couldn't use a different one. And so like I remember seeing this come through and really relishing the freedom it gave to like swap between different things. The problem with WSGI is that it is very much synchronous. And it's very much based on that request-response model of HTTP. It's built as this way where you have a function, you call the function with a request, the function returns a response. There is no real affordance there where you can make the function live for a long time. It's not an asynchronous function, it's from the early Python 2 days. And so you have to really think like, how do we take that and make it work for async? My first attempt, as you saw, was not great, full of weird networking layers. But the version that Channels uses, I am quite proud of, and I think it is a good replacement for that kind of thing. It is called ASGI because it's like Whiskey but with an A in it. It's very inventive naming on my part. And it is basically an asynchronous version of Whiskey. I'll give you a brief tour of it here. So your standard WSGI application looks like this. You have an application, it takes two things, an environ. The environ is the dictionary of data from outside, the environment. Things like, here are the headers, here's the request, here's the path from HTTP, all that stuff's in there. And start response is the callable you use to send headers back. So you get your environ, you work on it. So like Django requests basically read the environ, break the environ apart into a full request object for you and do path analysis and stuff. And then once you finish your business logic, you call start response, you send your headers and response code, and then you just basically yield or return data out to send over the socket. You can see here how it's not quite capable of doing long-lived connections, but it could be closer. So ASGI looks a bit different. It looks like this. The first big difference is that it is a class. The actual interface is it's a callable, it returns a callable. As you can see here, the class has a call method, but this is the easiest way to explain it. The first time you call it, you give it your scope. The scope is like the environ was. It is a place where all the data about the connection that is there when the connection happens comes to you. So for HTTP, this is things like the path and the method and the headers. For WebSockets, it's very similar. It's like, oh, here is the WebSocket path, here is the WebSocket headers, here's the sub-protocol they asked for. But for other protocols, it can be different. So for example, if you are a chatbot, this could be the room that your chatbot is in, for example, or a TCP endpoint, things like that. And so you get this information, and then the second callable is a coroutine, and you get given two things, a receive and a send. Because we have taken away the idea of when the connection opens from the request happening, because in a WebSocket you can open it and then send things all the time, we've taken away that sort of start of request from the scope. You don't really do much in the init here, down into the call method. And so what happens is you call the call method that's called, you get given these two awaitables, and it's your job as an application to sit there, await events from the outside world and receive. You'll get things like, oh, you got a WebSocket frame, you got a HTTP request, stuff like that. And when you get one, to send stuff back. The crucial thing is these are not raw. Much like WSGI, there is a specification for how things look. It's pretty close to WSGI on purpose, but things like HTTP, like the path is decoded for you properly. Things are split out. For WebSockets, you have a nice dictionary like, oh, here's the text data from the frame, here's the binary data from the frame. The decoding is done for you there as well. And so it is still high level, like WSGI is in that respect, but it also gives you the ability to do what you like. Because this is just a coroutine, you don't have to just receive and send. You can launch your own background coroutine. So for example, in channels, we have a base class of these that in its call method, before it even starts receiving, launches a second receiving thread that listens to the channel layer. And so all it's actually doing is listening on both the channel layer's async thing and on the socket's async thing. But because we can abstract it like that, we can just say, oh yeah, you have a coroutine, you can do what you like. As long as you clean up, you get a lot of freedom. And that means we can do things like do computations after you've sent the response. As long as you exit at some point, and the servers have a built-in 10-second timeout after the socket closes, you can do a lot of background processing or listening on different sockets, all that kind of stuff. But also, crucially, it is still pretty simple, and it's still an object you pass into your server. You still have an application you pass on the command line to your ASCII server, and it handles that kind of stuff for you. And one of the things I really wanted to reach here with this was a phrase I first heard, I think DjangoCon EU in 2009, called turtles all the way down. One of the goals with Django we never really got to was to have all those layers you saw be very similar. Like, why is routing and middleware and views all different? Like, they all have different interfaces, you can't write them quite the same, and there are reasons for that in the way WSGI and Django is designed. There was a push for a while to have WSGI middleware, and we still have this around, it exists in Python. Django is very bad at not using it for a variety of reasons that are partially our fault. But the idea is I want to try and fix that. Like, how can we come back to this approach and make it all the same again all the way down? And that's part of making it all async as well. You know, that routing I showed you in that layer is just a normal ASGI application. It's an application that you give it a dictionary that says this pattern goes to this other application, and it makes a brand new application. The middleware is applications that wrap other applications. The whole point is all the stuff in Django channels is generic and not particularly tied to Django at all. And the idea here is to try and free up some of that potential for mixing and matching Django stuff that we never really got to in the existing place. But then there comes a very interesting question. I've just stood up here for about half an hour and told you how I've taken Django, made a parallel version of it, and it has different asynchronous things, but I haven't really touched core Django. And what does this mean for core Django itself? Like, channels is a Django project, it's under the Django organization on GitHub, but it is still a separate project, it's not part of the core code base. And it's at this point we have to start thinking a bit more in the future. The real question we have is how much can we make asynchronous? Asynchronous code does not come for free, for two reasons. First of all, it takes effort to rewrite code to be asynchronous, and maintenance is not free or cheap. Pretty much everyone, apart from a couple of our Django fellows who work on Django, works on a volunteer basis, and our fellows are very busy triaging bugs and doing security work. We do not have a huge amount of people power that we can put behind a big project to rewrite everything to be async. One of the big blockers for this initially was the idea that if we moved, it would have to be a breaking change. What I've tried to do with channels too is to show that we can move things to be async and then keep a synchronous interface with those wrapper functions you saw earlier. But there's still a second problem, which is speed. Whenever you emulate across the layers like that, from async to sync or sync to async, you'll be dropping performance. If you're running in threads, Python threads are a natural performance hit. If you're trying to call async code and synchronous code, having to go up to that main thread and back again is going to be a performance hit before you even consider the fact that you're probably going to keep popping in and out of it as you keep doing it. And so there's a real problem there with like looking at Django and like all of Django's components and thinking, well, could we make this async, but would it be much slower? Like, Django has had performance problems in the past. We've tried to speed them up. There used to be a graph of Django performance release by release that got slower and slower that finally we managed to fix. And then the real big question is the ORM. Django, for better or for worse, is by complexity mostly ORM. It's a lot of where our complexity is, a lot of our maintenance goes there. And the real question is, what would that look like? Django's ORM is very particularly opinionated. It's designed from a time and from a place I really appreciate, which is like it's not a relational, like particularly SQL-based ORM. It is much more based on object and fetching. And it's got better over the years, and there are more relational parts. But it's all very declarative and quite simplistic in the way you handle it. And like, how could we even do that same stuff in an async term? Could we even do that? For example, one of the big problems I've run into with Python 3 async is that even if you're in an async context in a coroutine, attribute access is still synchronous. There's no asynchronous attribute access. And so if you override things like properties or accessors or get methods, you can't have async versions of those. A lot of what Django does relies on overriding like operators or attribute access, and you just can't have those transparently be asynchronous. One of the big problems we had with channels was that I made a middleware which put users onto the scope. It's a standard auth middleware, it's great. The problem is that when you are trying to take a cookie from the scope and turn it into a user object, that involves accessing the ORM. And this means you have to do it in a synchronous context because it's Django and it's synchronous ORM. But the problem is that on the request object, user is lazy. Until you look at user the first time, there's nothing there. It's sort of basically a promise. As soon as you look at it, the descriptor triggers, fires the ORM query, comes back, and then gives you the object. The problem we were having was that this was happening in the middle of an asynchronous piece of code. Like, well, we're in an async function, we try and get this thing.user, it goes away and starts running database queries. And that's going to make your event loop block. There was protection. What happened, in fact, was that channels worked out what was happening and said, no, you can't run synchronous code in an async loop and quit out. But it caused a bug and had to fix it in a nasty way, and it still remains. And like that becomes much more magnified when you think about it on the grander scale of like, could we even partially rewrite this stuff? Like, how would that work? Is there an alternate way of doing this? Can we make Django more pluggable? I said earlier that like, shareable middleware and WSGI middleware is this goal that Django never quite got to. Could we get back there? Is one of these routes to it based around that kind of stuff? I would really love to see Django be more pluggable. I nearly always every year hear a request for, well, I'd love to use Django part X outside of Django, but of course the settings often is the problem, pops up and comes in there. So like part of this is if we are rethinking Django at all, is there a way around that part of it? Do we finally like start separating out the ORM from the templates, from the views, from the caching, from the URL routing, for example? And all of these are pretty difficult questions. And then there's an even bigger question that's beyond Django itself. I have just stood up here and showed you what I call a replacement for WSGI. That is a bold claim to make. It is not an easy thing to replace, and it is arguably something that does not need to be replaced. It works very well, some Unicode problems aside, for the majority of Python web handling. And in particular, WebSockets are not a big demand thing. One of the differences between migrations and channels, everyone needs migrations but doesn't know they need it yet. Most people don't need WebSockets, they think they do need them. They're shiny, they're new, they're exciting. But the problem is socket programming is really hard. If you're a web developer, you are spoiled because you have this wonderful stateless protocol where like everything is reset every request, there's no persisting state apart from cookies. It's actually really well designed as a protocol to write against. If you try and go from that world on both the front end and the back end side into the world of WebSockets, it takes a lot of extra effort. There's new skills to learn. There's new debugging problems to learn. Load testing is even worse. Like load testing WebSockets is a thing that's not even a good tool for yet. There's some tools, they're half written, but it's not a thing we have a lot of good practice at. Even finding load balancers that understand how to load balance long-standing connections properly is difficult too. And so the real question here is that demand for asynchronous, long-lived protocols sufficient to think about replacing WSGI? And by replace, I don't mean replace, I mean sit alongside as an alternative, of course. But like, do we even need that stuff? And I've been pondering this for a while. WSGI is a stable state. It is written in a PEP-like fashion, but is not a PEP, at least not yet. One of the things I personally think is important for any kind of shall we say, wanting to be specification is to have multiple implementations. Thanks to the work of the team over at Django REST Framework, among others, there are now multiple ASGI servers, both Daphne and Unicorn, both just plug in and run stuff. The thing I'm really missing here is multiple frameworks. Like, what I've written works well for Django. I am not going to be happy until I know it would fit well into other frameworks as well. And for this reason, like, my reticence in many ways is like, I want to sit down with maybe Flask or Pyramid or something, one of the other big Python web frameworks, and like, hey, would this fit into their paradigm as well? Could we do similar things with this kind of stuff? There is a WSGI adapter inside ASGI. You can just run a WSGI app inside it. It's a superset. That's not really giving you any benefits. Why would you do that? There's an issue open, I think it was on the AIO HTTP track of like, oh, we should add support for this thing Andrew invented. And like, some wonderful person who was very, very enthusiastic opened it. And I had to sit with ones like, you can't just go and ask maintainers for things that give them no benefit, right? Like, if we're going to do this, everyone has to benefit. We have to agree that having that standard, having that swappability that WSGI gave us is important. And that's really the crux of the problem I ended up having here. And so my goal is to probably try and bring it to some kind of PEP form soon, and work with other frameworks and other servers to try and add support for it. But that is not the direct goal. The direct goal is to get Django working first and have that stuff proven and in production and on systems, and make sure this time the design decisions that we've made and we've proven through actually do work at large scale, that are things we want to support into the future. And then, of course, as I said at the beginning, do we want everyone writing async? Async is lovely. It opens a lot of wonderful new avenues for us to do things in parallel. It's also very difficult. And Channels very much has this philosophy of you can write sync, you can write async, they can coexist. But as you move more down the async path, it's easy to forget about synchronous code as well. And one of the things Channels does do is like, writing synchronous codes get harder and harder because a lot of the APIs are async ones. You have to wrap them a little bit. And I'm honestly not sure if I want to say that Python web should all be async. I'm not sure that's going to be a safe thing to do with the current way async IO works. Maybe there probably is improvements in the language, improvements in async IO itself, improvements in the frameworks and the way we make things safer. Like, HTTP is not safe. Django and Flask and everyone have worked to make it safe. I think that same kind of learning, same kind of process has to be done to async stuff as well, and especially WebSockets because they're particularly nasty, to try and make these things happen correctly. And then this ultimately becomes very existential, right? Like, what is Django? I've given this whole talk up here. I am but one member of the Django team. I have a particularly far-ranging vision for Django that I know some of my colleagues don't share. And ultimately, like, Django at the moment is defined by where it came from. It is this amazing web framework that came from a place of perfectionists with deadlines, with this need from a time when the back-end web was very much the only place. These days, we live in the world of the real-time web with rich JavaScript front ends, with native apps, all this kind of stuff. Django and Python in general are still very, very relevant, but much more as a back-end system. Like, the number of companies who use Django for templating is reduced, but the number of people who use Django for like business logic and models is still there. So the real question is, at some point, we should work out what is our place in this future. Like, before we start making decisions, before we start going, let's rewrite everything to be async. Is that what we need? Is that what people want? And one of these things, and the best way I find of doing this is to just give people options and work out what becomes more popular. And that's kind of one of the reasons Channels exists. It's like, here is this thing. It is a moderately competent rewrite of Django to be async. It has a lot of the same support. And then let's see what develops, what comes out of it, and how we can use that stuff to improve both Django and Python in the future. And with that, thank you very much.